Hello, today I'm going to talk to you about the basic characteristics of series and parallel circuits using an alternating current. First, a brief overview of impedance. Impedances are capacitors and inductors' effective resistance in a circuit. We know that the impedance of an inductor, or XL, is omega times by the inductance, where omega is 2 pi times the frequency. And the impedance of a capacitor is 1 over omega times the capacitance. To analyze an AC circuit, the same theories we learnt for a DC circuit can still be used, except the changing current and voltages must be accounted for. An example of this is changing Ohm's law from V equals IR, where R is the resistance, into V equals I times by impedance, where impedance is Z. This picture shows an AC circuit with a resistor, a capacitor, and an inductor in series. The total impedance of this circuit is equal to the sum of the impedances. And since impedances are resistance and measured in ohms, the voltage divider rule for DC series circuits still applies and can be used to find the voltage across any one of these elements. This picture shows an AC circuit with a resistor, an inductor, and a capacitor set up in parallel. Since they're in parallel, the inverse of the total impedance is equal to the sum of the inverse impedances. The current divider rule can be applied to determine the current through any one of the components. Finally, I have two images showing how capacitors and inductors values are added depending on how they're set up. Inductors act the same as resistors and are summed in series, and 1 over the total equals the sum of 1 over each of them in parallel. The opposite is true for capacitors, where if they're in parallel, simply add them and that is the value of the new capacitance. If they're in series, 1 over the total capacitance is equal to 1 over each capacitance added together.